Hello my beautiful PU1 champions. So today I am here to discuss the model paper that is given by the government. So yes, without further delay, let's get started. So full model paper we are going to solve here, and don't worry, you are going to get the PDF as well. So yes, let's start with the part A, MCQ questions. So here you can see the prefix used for the multiple 10 power minus 6 is given for micro, right? Wait just a minute, it's given for micro. Let's proceed further. Here you can see if two volumes of gas give one volume of A2 and one volume of V2, then molecular formula of the gas will be. Okay, so basically what it is saying that, let's say X is the gas, it is giving, let's say A2, one volume of A2 plus one volume of B2. Okay, so in order to balance this must be like two volume of the gas. So 2x is giving A2 and B2. Now if I want to find out the number of atoms, so number of atoms in 1x, it should be 2 by 2, that is 1, and number of atoms, this is number of atoms of A, number of atoms of A, and here number of atoms of B, that also should be 2 by 2. So here also you will get 1. Okay, so putting this together you will get the formula AB. So that's going to be the answer. So option B is the correct one. I guess it's clear to you. Let's proceed. An atom of an element contains 19 electrons in its nucleus, has 20 neutrons. Its mass number. Okay, so electrons and protons numbers are similar. So 19 electron means I'm having 19 protons as well. So 19 protons plus 20 neutrons, that will give you the mass number. So that is basically 39, right? Let's proceed. Here you can see the chemical properties of atoms are controlled by electrons. Next, choose the correct order of the atomic and ionic radii of chlorine atom and chloride ion. Okay, you don't have to remember the value exactly, but remember chlorine will be smaller and chloride, when one electron will be incorporated in chlorine, it will be, the atomic radii will be more, right? So here only one option you can see, this is 99 is for chlorine, 167 is for chloride. Let's proceed. Here you can see the valency of noble gas is going to be 0. Next, the conversion of O2 to O2 2 plus involves the removal of one electron from anti-bonding pi orbital. So basically what happens, let's say this is my 2p, let's say 2px, 2py, 2pz. This is also, let's say 2px, 2py, 2pz. So once they will form bonding, this is sigma, let's say 2px. After that pi 2py and pi 2pz, then pi star 2py and pi star 2pz, and above you will get sigma 2p, sigma star 2px. This is how it is, it looks like the final orbital, right? Outermost, right? If I draw the MO. So how many electrons are there? If I just put the electron now, 1, 2, 3, 4. Here also 1, 2, 3, 4. So in accordance to Hund's order, Hund's rule, if I fill it, 1, 2, 3, 4, 5, 6, 7, 8. So if you want to remove one electron, you have to remove it from here. So what is this orbital? Anti-bonding pi orbital. I guess this thing is clear to you. Let's proceed. The example of intensive property. Intensive property means that is mass independent. That's going to be temperature. Let's proceed. The change in internal energy value for an isolated system when there is no transfer of energy as heat or as work. So basically, if you just follow the first order, del U equals to Q plus W. So Q is also 0, W is also 0, hence internal energy is also going to be 0. Right? Let's proceed. Here you can see statement 1, equilibrium is possible only in a closed system at a given temperature. That's true. At equilibrium, all measurable properties of the system remain constant. Identify the correct statement. So definitely 1 and 2 both going to be correct. Next, here you can see match the following elements in compounds with their oxidation number. Okay, oxidation, oxygen in potassium superoxide. Whenever I'm just discussing about the superoxide, the oxidation state of superoxide is half. Always remember this. So with A, I'm going to put 2. Hydrogen in metal hydride, when it forms hydride, it forms always -1. So it's going to be 4. Sodium in rock salt, that's going to be +1, right? NaCl. Silver in silver amalgam, that's going to be 0. So check for the option, check for the option. D is going to be 3, C is 1, B is 4, option B is the correct one. Right? Let's proceed further. Here you can see which of the following will not show resonance. This is benzene. This will show resonance. Okay, look at this one. This is basically cyclohexane. Okay. This 2 hydrogen, 2 hydrogen. Now count the number of hydrogen and carbon. It's basically cyclohexane. There is no chance of showing resonance here. Okay, let's proceed further. An important property of carbon that has made carbon to be a backbone element of organic compound, that is the catenation, because carbon long chain can be formed, right? Proceed further. Special arrangement of atoms which can be converted into one another by rotation around C single bond are called rotamers or conformers. Okay. Which of the following reagent will produce transalkene from the reduction of alkynes? Sodium in liquid ammonia will produce transalkyne. If you give Lindlar's catalyst, that is H2 in presence of PD, BSO4, then you will get cis-alkene, right? Let's proceed. Okay, here comes the fill in the blanks. The element that is discovered by spectroscopic method, that is going to be rubidium. Okay, next, the electrovalence is always equals to the charge on the ion, right? So it's going to be charge. Next, if Bronsted acid is a strong acid, then the conjugate base is a weak base. Next, the element which has the same oxidation state in all of its compound is fluorine. There is no other chance, right? A compound A contains nitrogen, but Zedel's method is not applicable to estimate the amount of nitrogen in compound A. Then compound A is azo compounds. Okay, because azo means nitrogen double bond should be there. In that case, it's not possible for Zedel's method to detect nitrogen. Let's proceed further for the 2 marker. Okay. Before proceeding, let me come up with some information. If I know you are PU1 champions, and definitely in next year you are preparing for the KCET, right? So my dear students, the preparation begins from now on itself. So in order to make your preparation super strong, you can try free mock test given by Diksha Karnataka. So just below the video you will get the link, right? So once you will just click the link, you will get the mobile number zone. There you can put your mobile number and OTP you will get. Once you will put it, then you will get the free mock test. It's completely free, my dear, so that you can understand where actually you are belonging in accordance to your preparation for upcoming competitive examination. So don't miss out this channel, don't miss out this chance, I mean to say. So please go through the link and participate in this free mock test. Yes, let's proceed further. Okay, first question, you can see state Heisenberg's uncertainty principle, mention any one significance of it. So here you can see, as you know, it's impossible to determine simultaneously both the position and momentum of the moving particle like electron, okay, with accuracy. So that is the Heisenberg's principle, that is a mathematical law, that is mathematical form, delta x into delta px greater than equals to h by 4 pi. Okay, so in this case, if you just find out the significance, this is significant only for the motion of microscopic particle. For macroscopic element, it is not applicable, or you can say it's negligible. Proceed. The bond angle of SO2 molecule is less than 120 degree. Give the reason. So basically what happens here, lone pair bond pair repulsion. If I draw the structure of SO2, it looks something like that. You can see the lone pair and the pi electron cloud, they will repel each other. As a result of this bond angle will be reduced down from 120 degree to 119 degree. So main reason is lone pair bond pair repulsion. So shape of SO2 molecule is V-shaped, as you can see. Okay, mention two factors that determines the percentage covalent character of ionic bond. First of all, size of the ions, next is charge of the ions. So smaller the cation, always remember this is in accordance to the Fazan's rule, right? Smaller the cations, larger the anions, the covalent character increases. This is Fazan's rule. Okay. In order to charge, if I say higher the charges on either the cation and anions, polarization increases, covalency increases. Okay, remember this. Next, okay, the delta HF0 for L2O3 means formation enthalpy of Al2O3 is minus this much. Okay, write the thermochemical equation for decomposition of Al2O3 into respective aluminium elements. Just opposite reaction we have to write, means Al2O3 will be breaking down. You can see this is the reaction, Al2O3 will break down to aluminium and oxygen, and whenever it comes to the matter of thermochemical equation, you have to write down the enthalpy of reaction. So definitely opposite reaction, if you combine them, you will get the Al2O3. So this is just the reverse reaction, and hence enthalpy sign will be converted to plus. Okay, let's proceed. Define the specific heat capacity, write the relation between Cp and Cv. Okay, so what is specific heat capacity? Specific heat capacity is amount of heat energy required to raise the temperature of unit mass of a substance by 1 degree Celsius or Kelvin. Okay, next Cp minus Cv equals to R, that is the relation. Please don't forget to go through the derivation of this particular equation as well. Proceed. Okay, plot a graph of concentration versus time for the attainment of the chemical equilibrium for a reversible reaction. H2 plus I2 gives 2HI. Okay, so here from either direction it is given. Okay, so let's say H2 and I2 is giving HI. So H2 and I2 initially they are at the top because the concentration is maximum. So slowly with time the concentration will be going down and HI will be going up. Now let's take the reaction in the reverse way. So HI, from HI we are starting. So from HI we are starting, see, so here concentration is decreasing slowly and H2 plus I2 it's going like that. Okay, so this is the graph from either side. Okay, let's proceed. Okay, what are the effect of the following condition on equilibrium for a given reaction? So addition of argon gas at constant volume. So whenever you are keeping the volume constant, means there will be no effect on addition of inert gas. Okay, why? Because the molar concentration or effective concentration that is taking part in the reaction is going to be fixed, because argon is an inert gas that's not going to take part in the reaction, right? Next, increase in pressure. If you increase the pressure, then the reaction will proceed towards a direction where there are lesser number of moles. So here I can see 3 plus 1 4 moles, and here I am having 2 moles. So if you increase the pressure, it will go towards 2 moles direction, means it will go forward. Okay, I guess it's clear to you. Let's proceed. Okay, give any two differences between inductive and electromagnetic effect. You can see so many effects are there, so you can just take any two out of it. It's a permanent effect, temporary effect, strong effect, weak effect, like that you can just put. Okay, let's proceed. among primary, secondary and tertiary carbocation, which is more stable, give reason. So definitely tertiary carbocation is going to be more stable. Why? Because I am having 9 hyperconjugable hydrogen to give it stability, or you can say that 3-methyl group will give plus I effect. For that also it can be stabilized. Okay, proceed. What happens to the boiling points of isomeric alkanes with increase in branching? With branching, what happens? The surface area decreases, boiling point decreases. Okay, I guess it's clear. Okay, next question you can see, define ionization energy, mention any 2 factors that affects the ionization energy. So ionization energy, as I just already mentioned here the definition, please don't forget to mention that term, isolated gaseous atom in its ground state. So what is ionization enthalpy? Again, the minimum amount of energy required to remove the most loosely bound electron from an isolated gaseous atom in its ground state. Okay, as a result of this, it gets converted to a cation, right? So now factors affecting, like you can say atomic size. Okay, so atomic size, if it increases, the valence electrons are further, it gets further away from the nucleus, right? So removing that electron becomes easier. Right? Next is effective nuclear charge. If effective nuclear charge increases, then what happens? Then the nucleus will hold the electron with all of its strength, right? Then it becomes difficult to remove the electron from the outermost orbital. Ionization enthalpy increases. Okay, let's proceed. Write 3 conditions for the linear combination of atomic orbitals is LCAO. Okay, so number 1, same energy level. Okay, whenever two orbitals are there combining or overlapping, then let's say one 1s, right, it can combine with another 1s only efficiently, okay, because they are of same energy. Okay, next is same symmetry. Same symmetry in the sense, let's take an example. If you take z axis as a molecular axis, then z is like that, x like that, y like that. Then px and py, they are of, and they can combine with another px and py because they are parallel, they are lateral to each other. Though as a result of this, you can see the overlap will be prominent. Next is maximum or effective overlap. So here in this case, we have to check so that the overlap becomes the maximum. Okay, so greater the overlap, it will result the maximum electron density. As a result of this, more stable bond will be formed. Okay, let's proceed. Here you can see, using molecular orbital theory, calculate the bond order and magnetic property of carbon. Okay, let me just draw this MOT for you. Just follow me. Okay, so first I will just draw this energy axis. Okay, so here one carbon, here one carbon. So let it be atomic orbital of one carbon. This is atomic orbital of another carbon. Here in the middle we will draw MO of C2. Okay, let me just draw this lines a little bit up. Okay, so first what will happen? First we will draw 1s. This is my 1s. This is also my 1s. So they will combine to form one sigma bonding orbital. Sigma 1s bonding, another one is sigma star 1s, that is the anti-bonding. Let's do 2s. Same thing will be done for the 2s as well. One bonding, one anti-bonding. Sigma star 2s. Another last one is 2p. So let it be 2px, 2py, 2pz. Here also same 2px, 2py, 2pz. So one sigma bonding here also. Let it be sigma 2py or z. let it be Z, okay, sigma 2p Z, Z is the molecular axis, sigma 2p Z. Then I will be having pi, right, I will be having, let's say, pi 2p Y and pi 2p X, okay. Further if you go ahead, pi star 2py, pi star 2pz, and finally you will end up with sigma star 2px. This is the MO orbital, okay. Now we have to put the electrons. So what is a electronic configuration? 1s2, 2s2, 2p, 2. So 1s2, 2s2, 2p, 2. Right? Now let's proceed. In accordance to Hund's rule, we will fill up from the below to up. 1, 2, 3, 4, 1, 2, 3, 4. Here how many? 1, 2, 3, 4 total. 1, 2, 3, 4. Okay, so this is how it becomes. So you can say that C2, it overall it comes pi 2px, pi 2py. I am having unpaired electron, hence it is paramagnetic in nature. It is paramagnetic in nature, okay. And if you say bond order, if you have to calculate, then half into number of bonding electron means 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 1, 2, 3, 4. 4. So total it's coming 1 by 2. So total it's coming 2. So bond order is coming as 2. So I guess it's clear to you. Let's proceed. Okay, what is the Lewis symbol? Give one significance of this symbol and write the Lewis symbol of ozone molecule. So here you can see what is Lewis symbol. Whenever the valence shell electrons are represented around the atom as a dot, right, and outermost electron, okay. So now here you can see ozone for ozone molecule, it's something looks like this, okay. Let's proceed. Okay, in the following redox reaction, 2Fe plus 2HCl gives FeCl2 plus H2. Fine. What is the oxidation state of iron in FeCl2? Very easy. This is 2 plus. Then what type of redox reaction is this? It's a single displacement reaction. From class 10th level you are doing it. It's a single displacement reaction. And identify the species undergo oxidation. That is definitely iron, because from 0 oxidation state it is coming to plus 2. Let's proceed. Okay. What is the molecular formula? How it is related to empirical formula? So molecular formula represents the actual number of atoms of each element that is present within the compound. Okay, how it is related to empirical formula? Molecular formula is basically n, empirical formula whole n, that's it. Okay, now give an example of the compound whose empirical formula and molecular formula is same. H2O, carbon dioxide, CH4, where the value of n becomes 1. Okay, I guess it's clear. Okay, a neutral atom has 2 electrons, 8 electrons and 6 electrons in KLM shell. From this predict the atomic number. Okay, let's count the number of electron. 8 plus 6 plus 2. 8 plus 6 plus 2 comes 16. So 16 is the number of electron present. Okay, so number of proton will be 16 as well. So atomic number is 16. Okay, total number of s electron. So atomic number it's coming 16. So total number of s electron. Now let's proceed. 1s2, 2s2, 2p6. See how many it become? 10 already, right? 3s2, 10 plus 2, 12. 3p4. This is the electronic configuration. Now total number of s electron 2 plus 2 4 plus 2 6. 6. Total number of p electron it's coming 6 plus 4 10. Okay, I guess it's clear to you. Okay, let's proceed further. Write the Gibbs equation to the relation between the free energy change, enthalpy and entropy. This is called Gibbs-Helmholtz equation, delta G equals to delta H minus T delta S. Please mention the abbreviation. What are the conditions for delta H and delta S for a reaction to be spontaneous at any temperature? Means delta G must be negative. So what is the condition? Delta H also should be negative and delta S should be positive. Then under any condition this del G value will come as negative. Okay, let's proceed. What are the buffer solutions? Give an example of neutral buffer. Write Henderson-Hasselbalch equation, calculate to calculate the pH. Okay. Buffer solution is those solution that prevents when some little amount of acid or base is added, it prevents the pH change of the particular medium. Okay, so you can see this is the definition, and one neutral buffer is ammonium acetate. Henderson-Hasselbalch equation is this one. Okay, so I guess it's okay. Let's proceed. Okay, for the following figures predicting the direction of reaction, here you can see this is QC lesser than KC. It represents the forward direction reaction. Okay, if you can see QC greater than KC, it represents backward direction, means toward reactant. If they are equal, then it represents equilibrium condition. Okay, proceed. Okay, so here you can see for the compound this Cl2CH, CH2, CH2, OH, write the IUPAC name and bond line formula. Okay, so here you can see this is the name, that is, let me just show you here, 1, 2, 3. If I number it like that, in the 3 position I am having 2 chlorine. So 3, 3 dichloro, how many carbon? 3 carbon. So propan in the 1 position, all. 3, 3 dichloro propan 1 all. Okay, write the IUPAC name. I guess you got it. Now if I just draw the bond line structure, just split the bonds in every possible way. Like this you can draw the bond line structure. Okay, now what are the functional group? Here chloride and hydroxide. Next, suggest a method to separate the constituent of the following mixture. Mixture of 2 miscible liquid you can separate by fractional distillation method, and a mixture of plant pigment you can use a chromatography. Okay, adsorption chromatography. Proceed. Okay, complete the following reaction. So for this case you can get first case alcohol, next case one aldehyde, and third case one ketone. Okay, let's proceed. Okay, here you can see one alcohol, in the next case you will get one aldehyde, in the next case you will get one carboxylic acid. Okay, let's proceed. Write the mechanism of the chlorination of benzene, define the polymerization. Okay, chlorination will be having 3 steps. One is chain initiation, chain propagation, and chain termination. In initiation step, chlorine will break down in free radical. In chain propagation, what happens that chlorine free radical comes to methyl group, CH4 group, right, and it breaks down the methyl group in methyl radical, CH3. Okay, it breaks down methane in methyl radical, right. Then what happens, the CH3 dot and Cl dot, they make the bond CH3Cl. In termination, all the possible combination can happen. CH3 can make a bond with Cl, CH3 can make a bond to form CH3 like that. This is chain termination. Okay, so 3 marker question. Next, define the polymerization. Mention any one use of polymer. So here comes the next thing. This is basically what is polymerization? Whenever from a monomer or a small unit that will be repeating multiple times to give you a very big unit. Okay, that is called polymer. Okay, now one use is like PVC, polyvinyl chloride, which are nowadays used. It is used in different type of home appliances or something like that. Okay, some commercial products. Okay, for the piping, insulation, packaging, like this. Okay, proceed. Okay, now the numerical portion we have come up. So yes, let's proceed with the first numerical. Naturally occurring chlorine consists of two isotopes with atomic weights 34.9 and 39.5, and their abundance is 75.6% and 24.24% respectively. Calculate the relative atomic weight of chlorine. Okay, there is a formula basically. If I want to find out the percentage abundance, right? Percentage, wait, what they are asking? Calculate the relative atomic weight, sorry. So I have to find out the atomic weight. So what is the formula? That is basically mass of the first isotope into percentage abundance plus mass of the second one into percentage divided by 100. Let's put the value. So first one is 34.9 into 75.6, right, plus 39.5 into 24.24 divided by 100. Okay, if you just calculate this, it will come up to be something like 35.95. That is the relative atomic weight. Okay, I guess it's clear. Let's proceed further. Okay, so here calculate the energy of 1 mole of photon of radiation whose frequency is 5 into 10 power 14 Hz. Okay. So first what we will apply, E equals to h nu. We will calculate the energy of a single photon at first. So h is 6.626 into 10 power minus 34 joule second into new value is given as 5 into 10 power 14. Hertz means second inverse. So second inverse will be cancelled out. So if you calculate this, it will come up to be something 3.313 into 10 power minus 19 joule. Okay, now we have to calculate the energy of 1 mole photon. Okay, so that will be, just multiply this thing with 1 mole. 1 mole means Avogadro number. So 3.313 into 10 power minus 19 joule into 6.023 into 10 power 23. So if you calculate this, it will come up to be something like 199.51 into 10 cube joule. From here I can write 199.51 kilojoule. That is the answer. Okay, I guess this is clear to you. Okay, so let's proceed with the next question. Okay, here you can see the combustion of 1 mole of benzene at 298 Kelvin and 1 atmosphere liberates this much kilojoule of it. Okay, calculate the standard enthalpy of formation of benzene. Okay, standard enthalpies of formation of CO2 and H2O are given. Okay, fine. So what are the things given? That at first write, you are given with let's say C6H6 means combustion of benzene, right, plus O2 will give you CO2 plus H2O. So if I balance it, it will be something 6 CO2 and here 3 H2O. Here I am getting 15 by 2 O2. Here delta H value is given as 3267.0 kilojoule per mole. Okay, so now you can see liberated this much of heat, so it should be minus, means exothermic reaction. Fine, this is my equation number 1. Okay, let's proceed with equation number 2, that is formation of CO2. So C plus O2 will give you CO2. Okay, C plus O2 will give CO2. For this, delta H value is also given as minus 393.5 kilojoule per mole. Fine. Equation number 3, if you see, that is H2 plus half O2 will give you H2O, right? For this case, delta H is given as minus 285.83 kilojoule per mole. Okay, so from here where I have to come up? I have to come up formation of benzene, that is 6 plus H2 will give me C6H6. If I balance 6 carbon plus H2 will give me, for this equation I have to find the delta H. So I have to arrange these three equations in such a way so that I get the final one. So what I am doing, you can see, what I can do is, you can see, I am doing equation 2 into 6 because I need 6 carbon, okay, plus I am doing equation, okay, here also I need 3, so 3 hydrogen I need, right? So equation 3 into 3, right? Then 3 hydrogen will come, okay? Then what I can do, minus or reverse of equation 1 I can write, plus reverse of equation 1, or minus, let's write better, it will be easier for you to understand. Okay, minus I can do equation 1, okay. So overall if you just write equation 2 into 6, 6C plus 6O2 will give you 6CO2, right? Along with that, 3 into equation 3 into H2 plus 3 by 2 O2 will give you 3H2O, okay. Now minus equation 1, minus C6H6 minus 15 by 2 O2 will give you minus 6 CO2 minus 3H2. Everything will be cancelled out, you can see. Everything will be cancelled out and you will get C6H6 will go that side and you will end up with 6 carbon plus 3H2 will give you this thing, C6H6. Fine. So I got the final equation. Now let's calculate the value. Where should I calculate? Let me just erase this part. Okay, no, let me just do it here. Sorry. Let me just do it here. So basically what I'm getting, 6 into minus 393.5 plus 3 into minus 285.83, and as I'm like subtracting that, so minus of minus 3267, okay. So if you calculate this, your value will come up to be something like minus 41.51 kilojoule per mole. That is your answer. Okay, I guess it's clear to you now. Let's proceed further. Okay, so next question here, you can see the value of Kp for the reaction of this is 3 at 1000 Kelvin. If initially PCO2, pressure of CO2 is 0.48 bar and pressure of CO is 0 bar and pure graphite is present, calculate the equilibrium partial pressure of CO. Okay, so let me just write down the reaction once again. That is CO2 plus C, it is in the solid state because graphite will give you 2CO. Okay, so now what you have to do, Kp, if you just okay, normally just if initial pressure they are saying for CO2 it is 0.48, this is not yet formed, hence it is 0. Now whenever it is at, let's say at equilibrium, At equilibrium what happens? 2x amount of this will be formed and this will be 0.48 minus x, right? Yes. Now I am having Kp. So Kp is basically equals to pressure of CO whole square divided by pressure of CO2. Solid we will not take. Let's put the value. Kp is given, that is 3.0 equals to 2x square divided by 0.48 minus x. Okay, let me just take it here. So from here I am getting a quadratic equation. You can see 3.0 into 0.48 minus x equals to 4x square, right? From here if I calculate this, 1.44 minus 3x equals to 4x square. From here 4x square plus 3x minus 1.44 equals to 0. So I'm ending up with a quadratic equation. So now if I solve with a Sridharacharya, that is minus b plus minus under root b square minus 4ac divided by 2a, right? So if I put the value, that's going to be minus 3 plus minus b square means 3 square, right? Minus 4 into a value is 4. 4 into c is minus 1.44 divided by 2 into 4. Okay, so if I just calculate this and if I just take the positive root of x, definitely negative value, x cannot be negative, right? Then you will end up with some value of x that is going to be 0.3325. Okay, this is your x value if you calculate this. Okay, now once you got the x, from here you can calculate pressure of CO, that is going to be 2x. Right, so 2 into 0.3325, that's going to be 566, okay, 0.665 bar. Okay, and pressure of CO2 if you want to calculate, that is 0.48 minus x, that going to be 0.48 minus 0.3325, that's going to be 5.741, okay, 0.1475 bar. That's it. This is your answer. Okay, I guess this portion is clear to you. Let's proceed further. Okay, let's proceed with the next question. Here you can see in Carrier's method, the estimation of sulfur, it is 0.466 gram of barium sulfate formed from 0.32 gram of organic compound. Calculate the percentage of sulfur. Okay, here we are going to use simple formula. What is the formula? So percentage of sulfur is going to be molecular weight of sulfur divided by molecular weight of barium sulfate into weight of barium sulfate divided by weight of organic sample into 100. Let's put the value 32 divided by 233, it's already given out there. Weight of BSO4 is given as 0.466 divided by 0.32 into 100. So if you calculate this, it will come up to be something like 20%. Okay, so yeah, that's your answer. I guess you understood this. Let's proceed. Yeah, that's it. So I guess you already understood the entire model paper, and please comment me below if you did not understand any concept, or if you want any concept to be cleared in one short video or something like that. And don't forget to like, share and subscribe. Thank you for watching the video.